Hey, what's up, GRE lovers? Today, what we're gonna do is we are going to look into this shaded area problem and kind of like come up with a simple method in which we can basically tackle these daunting and intimidating questions. So before we actually dive into this, let's try to come up with a simple method or a technique in which we can kind of like solve these problems. So the first thing that I kind of like expect you to know is like what is a subunit. So basically a subunit is basically a small sample which can kind of like represent the overall population, the overall idea. So let's say if there is a small piece which can represent the overall idea, all you have to do is kind of like find the area of one piece, just one piece, and multiply the times it is appearing, and then you're going to get the overall total shaded area. The second is basically your ability to kind of like make these, shape equations. And what basically the GRE is testing over here is your ability to kind of like understand how these kind of like shape interact with one another and how they kind of like overlap and what you need to consider while adding or subtracting, that kind of thing. So a simple method is basically, first of all, you need to focus on what is required. What is the basically question demanding? And the way to get that is basically you start with the total and then you subtract which is not required, basically required prime, not required. So if you have basically a good grip of this understanding, then I believe that tackling these type of questions is not going to be that much difficult for you. So let's dive into the question. The question says the figure shows have 5 congruent circles. So all of these 5 circles are basically the same. ABCD forms a square. So ABCD is a square, therefore all sides are equal, with each side 4 units. So all of the sides are basically 4 in length, and its vertices lie at the center of the 4 circles. So all of these 4 circles, these vertices, are basically the center, which basically gives me some information, because if the total is 4, then I know that the radius for every circle is going to be 2. Anyway, then it says where the 5th circle is shown inscribed within the square. So this, the 5th one is basically inscribed in the square. Find the area of the shaded region. So basically the question is asking about the area of these 4 leaf-like shapes, and don't worry if it's really complicated right now. Once I will describe the whole method and how it works, everything is gonna make sense. So if you kind of like come down here, just to save time, I've probably sketched this kind of like shape already, in which the only thing I think I really need to do is kind of like label it that the sides are all 4. And the question is basically asking for, can you find the area of, these 4 leaf-like shapes? Okay, right over here. So if you come back over here, the first thing that you should be considering while tackling these type of questions is kind of like dividing the overall diagram into its one subunit, which can, represent the overall population. So if you come back down here, if I can just find the area of just one leaf, then basically I kind of like can just multiply that 4 times and get the overall area, which basically I'm looking for. So if I want to kind of like show what I really mean, let me just focus on, oops, this is what I was not expecting. No worries, we can draw another box. Okay, let's try be a bit careful this time. Careful, oops. This is not working. Okay, let me just use it manually then. So what I'm gonna do here is kind of like, I am using green, right? Yeah. So what I'm going to do is basically consider this small block, which is basically representing the overall square, right? And what I can do is basically kind of like extract it out over here. Let me use the shape now. I think it will be okay to use now. I hope it is. Let's finger cross. Okay. Yeah, it's working. So basically what I've done here is I've kind of like extracted this small square and kind of like taken it out. And I already know since the overall is 4, then this must be 2 and a 2. And basically what I'm interested in is basically this leaf kind of like shape over here. And if I draw it like over here, yeah, this is the area which I'm basically interested in. So if I want to get to this area, again, I need to kind of like consider what do I want or required and get the total and subtract which I don't want. So over here, the area which I basically don't want is this over here and this over here. So how can I kind of like make up an equation for this shape over here? So again, if you come back over here, what is required? I'm going to scroll back down. So what is basically required is this, shape like this leaf-like shape. And basically it is the total, which is basically the square. Let's draw a square this time. Okay. And its area, by the way, it's like super easy to find. It's like 2 and a 2, so area is going to be 4. However, the things get a bit tricky because you need to subtract these two L-shaped areas. I'm going to put them in a bracket because I need to add them. So the first one which I really want to remove or which I don't require is this L shape over here and plus another, I believe, L shape over here, kind of like this. If I add these two up, and I subtract it from this area of 4, which has 2 and a 2 sides, I'm gonna get the area of this leaf-like shape. However, things don't simply end there because again, this is just one leaf and I'm looking for total 4 leaves. So what I need to do is kind of like take this overall equation and kind of like multiply it with a 4 so that I finally get the overall shaded area. So now that we are basically done with our simple basic shape equation, I think we can focus on more on the shapes that we need to kind of like add or subtract. So I think this is pretty much easy to calculate. Let's shift our attention to this over here. So these are the two areas that I need to kind of like remove from this square in order to get this leaf. So initially, when I was kind of like describing this during the class to one of the members, I kind of like said, hey, you know what? These two L shapes are kind of like equal, but there was like a lot of confusion. So I kind of like struggled a bit to kind of like explain. So there is like a mathematical way, and there is a lot more easier or intuitive way to kind of like understand this. So how come these two shapes are equal? So let's say you have a pastry, which is square in dimensions, and let's say you kind of like took a bite from here, and this is kind of like the arc of your teeth, and this is the stuff that you took out, okay, and this is what is left. Now again, the same pastry, but now what happened was that you took a bite from the opposite corner. And now, basically, you took a bite and the shape of your teeth is kind of like this. So this is the area that you ate, and this is the leftover. So given the fact that you took the same bite and the dimensions or the radius or the arc didn't change, these two areas or leftovers are gonna be same. So using this kind of like a simple analogy, you can kind of like understand this intuitively. You can do this mathematically by giving dimensions, but that would be a bit too tedious. So I think this is enough. So now that you have kind of like realized that both of these, L shapes are kind of like equal, you can kind of like modify this equation by saying, okay, so I can say 2 times this just one inverted L shape, which is basically a leftover that I need to subtract from this square, okay, which has an area of 4. And if I do that, I'm gonna get the area of this leaf over here, And finally, just need to multiply the whole thing, final product, with the 4, because again, there are 4 leaves to get the final answer. So now that we are pretty much done here, the reason why this question is so important and pretty interesting is you're applying the same equation twice. So now that we are done, now we need to focus on this shape over here. So how do we get this, inverted L shape? So if you come down over here, let's see, like, again, what is required? This is the shape which I basically need to kind of like take out, right? So it is equal to, what is the total? Well, total is the square, right? Total is the square. Again, super easy to calculate the area because it's just 2 times 2. The area is going to be 4. However, the thing that I really need to remove, if you come back up here, is remember that there is this 1/4 circle, or the byte, that you need to take out in order to get this leftover. So what I need to do basically is kind of like take out 1/4 circle, which is basically, and the radius of that is going to be 2, right? So how would I say, okay, the 1/4, the area of the circle is pi r square. Since the radius is 2, it's going to be 2 to the power 2. And I can like eliminate this 4 and this 4. And if I kind of like do a simple simplification, this left over, this inverted L shape, is basically 4 minus the pi. Okay, 4 minus the pi. And now since I am basically done with my initial analysis, all I need to do is plug in this value all the way here to this equation, and we're pretty much good to go. So if I plug this value over here, what I'm basically going to do is probably cross this out over here. I need to kind of like -2 times this value over here, which is 4 minus pi, right? So, and this 4 is just gonna come in front of it. So let's do some simple math simplification. What's this gonna be? 2 is 8 minus plus negative times negative is a plus 2 pi, and then we have this 4. So this is going to result in a -4 plus a 2 pi. So this is the final area of this leaf right here. However, the final thing which I'm basically missing is multiplying this 4 in order to get the overall total area. So all I'm doing now is basically multiplying all of this with a 4. So 4 times 2 is 8 pi, and with a -16. I can take 8 as a common and be like, okay, 8 is a common, then pi minus the 2. So this is the overall shaded region of the 4 leaves. And if you come back up, the answer must be D. Okay, guys, this is it for now. So the takeaway over here is your ability to understand kind of like subunits, which is basically a simple unit which can describe the overall population, and your ability to make these shape equations. And the way you make it is simply, hey, what is required, what is the total, and what do I need to subtract? So this is a pretty good problem, a nice little GRE level problem. I hope it was edifying. Okay, guys, this is ABD is signing out, and I'll talk to you guys later. Bye-bye.